Okay, today we're talking about volume. Okay, now volume is kind of like area. Okay, area was the space inside of a two-dimensional shape. Okay, but volume isn't for shape, it's for figures. So volume is the space inside of a three-dimensional figure. Okay, so area is just two-dimensional because it's the space inside of a two-dimensional shape. And that means volume is going to be three-dimensional because it's the space inside of a three-dimensional shape. Okay, so let's look at one. We're going to look at prisms. Alright, so we have a prism here, which is going to be the main focus of what we're looking at today. Okay, and we're trying to find how much space is inside this prism. Okay, well, you kind of just did an activity, so we'll talk through it. Well, first, can we figure out how much space is on the base of this prism? So just kind of this section. Well, sure we can. That's just finding area, right? It's just the area of the bottom. We can find how much space is there. Okay, well, how does that help me find how much it would take to fill up the prism? Well, if I just stacked these little rectangles on top of each other over and over again to fill it all the way up, wouldn't that be how much space would be inside that prism? Okay, so just to give you a little visual, we have the area of the base and we have the height of the prism. Okay, these are our two important pieces because what we're essentially doing, how we form the prism, is we just kept stacking this base on top of itself until it was the height of the prism. So we're just stacking it. There's another one, there's another base, there's another base. Now, of course, there wouldn't be any space in between these, but I can't really draw them that way, so I put a little space. So, but I'm just stacking base on top of base on top of base on top of base until it's the same height as the prism. So, and then when I get to the top, I have my prism. So how would I figure out how much space all of these rectangles have? Okay? Because all of this space would be the volume. And that's what I want. Okay? So the volume, okay, is the amount of space on one of them is the area, right? So I have the area of the base. And then I multiply it by the height because that's how many of those rectangles, or whatever shape it is, that I would have to stack on top of each other to make that prism. So I'm multiplying by the height. Okay, so this capital B stands for the area of the base, and the H stands for the height of the prism. Okay, now don't get that confused. Okay, capital B is the area of the base. Okay, it's a capital letter because it's something we have to calculate. Okay, lowercase letters are something you can just look at the shape and find the measurement. Capital letters are something you have to calculate. Okay, so you have to calculate the area of the base, and then the H is the height of the prism. So it's just whatever this number is here, and you multiply the area of the base times the height. Now, if you remember back when we were finding area, what did we know about base and height? Now it's a little bit different kind of base, but it's still the same. Base and height always have to be perpendicular. Okay, so if the bottom of this is the base, then the height has to be going up. But if I had called the front of this prism my base, then the height wouldn't be going up because that's not perpendicular. If the base is the front, then the height would be this line here. How far back does it go? Because that's perpendicular to the front side of this prism. Okay, so height isn't always vertical. Height isn't always up and down. Okay, it's always perpendicular to the base. This base is flat on the bottom and the height goes straight up. That's perpendicular. So that's the base and the height. All right, but this is my formula. Volume equals the area of the base times the height. This formula works for any prism. Okay, no matter what kind of prism, it works for every single one. All right, so let's look at a rectangular prism. All right, so this rectangular prism, okay, is 6 feet across, 5 feet deep, and 5 feet tall. Okay, so we need to find the volume. Well, the volume is the area of the base times the height. So first, we need to find the area of the base. That's this part. Okay. Now, it's a rectangular prism, so I could have really chosen any side to be the base. I chose the bottom, though. Okay, so this is a 6 by 5 rectangle. So I need to find the area of that base. So the area of the base is 6 feet times 5 feet, which is 30 feet squared. All right, so I just found the area of that rectangle. Now, for the height, that's just 5 feet. Now, how do I know that that's my height? Is it because it's up and down? No, it's because I chose the bottom, the flat part, to be my base, so the height has to be perpendicular. All right, so now I have that my volume equals 30 feet squared times 5 feet. So I can just multiply. So I get 150 feet cubed. Okay, now notice, because I did feet squared times feet, I get feet cubed to the third power. Does that make sense? Because volume is three-dimensional, that's why it's feet cubed, or units cubed. It's to the third power because it has 3 dimensions, because we multiplied feet times feet times feet. Okay, so just like area is always squared, volume is always cubed. Now, since, like I said, I could have picked a different side to be the base, I'm going to do that and let's see what happens. So this time, I'm still going to use the same formula, but I'm going to pick this side to be my base. Okay, so the blue, I'm in the blue now. So this is a 5 by 5 rectangle, or a square. So the area of the base is 5 feet times 5 feet. Okay, so that gives me 25 feet squared. And I see now, this time, the height is the 6, because this face and this length are perpendicular. So if this is my base, then this is my height. Okay, so times 6 feet, and when I multiply those, I get 150 feet cubed. Notice, I got the same answer. It does not matter which one you call the base and the height. As long as the base and the height are perpendicular, you will get the correct answer. Now let's look at a triangular prism. Okay, same thing, it's still a prism, so we can still use the same formula. Volume equals the area of the base times the height. Now notice, this time these are right triangles, so this is the height of my triangle and the base of my triangle. Okay, now first I need the area of the base. Well, I'm going to use this triangle. Now I don't have many choices this time. I can only use this triangle or that triangle. Those are the only two bases, and since they're the same size, it doesn't really matter which one I use. Okay, so I'm going to need the area of that base. Well, you have to remember how to find the area of a triangle. So that's 6 meters times 4 meters divided by 2. So the area of the base is 12 meters squared. And if the base is this edge here, this side here, excuse me, then that means the height must be the one perpendicular to it. Okay, so the height is 8 meters. So volume equals 12 meters squared times 8 meters. So now I can multiply and I get 96 meters cubed. Okay, notice it's basically the same as the rectangular prism. It's just when you find the area of that base, well, that base this time happens to be a triangle, so you find the area of it like a triangle. That's the only difference. Okay, you still do the area of the base times the height, and that's it. Now let's look at the one that almost fit into that category but didn't quite. A cylinder, right? I told you before that a cylinder basically is a prism. It just happens to have a circle for the base. Okay? So we can actually find the volume of a cylinder the exact same way as a prism. So we're going to use the same formula. Okay? Volume equals area of the base times the height. Okay, well, what is the base this time? Oh, well, the base happens to be this circle. Well, we know how to find the area of a circle. Okay, so the base equals pi r squared. So pi times 3 squared. Well, pi times 3 squared is pi times 9. So the area of the base is 28.27 meters squared. Okay, so now that I know the area of my base, then my height must be perpendicular to it. If this side is the base, then this must be the height. Okay, so times 10 meters, and I can multiply those together, and I get that the volume equals 282.7 meters cubed, and that's the volume of this cylinder. Now notice, again, I did the same thing as both previous prisms. The only difference was when I found the area of the base happened to be a circle. So I had to find the area of that circle. But nothing else changed. I'm just finding the area of the base and multiplying by the height. That's it. All right? So you can use this formula for any prism or cylinder. Okay? And it will work every single time. Now, I do want to go back and let you know that some people like more specific formulas. They like a formula for each prism and the cylinder. Okay, so I'm going to show you those as well. Okay? But they'll make perfect sense if you understand the formula we've already used. Okay, so for a rectangular prism, notice we always had to find the area of the base and multiply by the height. Well, the base of a rectangular prism is always going to be a rectangle, right? So you're always going to be doing the length times the width, correct? So this base is really just length times width. So for an explicit formula that's always just works for rectangular prisms, you can just do volume equals length times width times height. Because isn't that the same as the area of the base times the height? Because the area of the base is just length times width. So you do length times width times height, and you get the volume of a rectangular prism. Now, you can use either formula because they are the same. So whichever one seems easier to you, that's fine. Now, we have the same idea for a triangular prism. Okay, again, you can use our first formula. It's just fine. Or let's think about it. Again, area of the base, but this time the base is always a triangle. Okay, which that's the length times the width, but then also divided by 2. So this base, the area of the base, is really 1/2 of length times width. So really this is just 1/2 times length times width times height. So we could write this volume as 1/2 times length times width times height. So for an explicit formula, you could just do length times width times height divided by 2, or times 1/2. Okay, again, you could use either formula you want. Okay, and on the cylinder, we have again the same thing. Okay, but this time the area of the base is always a circle. Well, how do we always find the area of a circle? That's just the radius. Okay, so it's pi r squared. So this area of the base is really just pi r squared. So instead of area of the base times height, you could just do pi r squared times height. So you have the volume equals pi r squared h. And that's the formula for all cylinders. Now, personally, I like using the one formula that works every time. Okay? Other people like to memorize the other 3 formulas because maybe they think individually they're easier. But really you're doing the same thing. As long as you know how to find the area of a circle, then you already know this. And as long as you know how to find the area of a triangle, you already know this. And as long as you know how to find the area of a rectangle, you already know this. So that one's pretty easy. But either way, you can use any of the formulas that you want. Now for some practice. Okay, this time you're going to find the volume of each figure. Okay, I'm not going to tell you what shape it is, although you should be able to tell. Okay, so we have 3 figures. Okay, I'll run through the numbers real quick. This is a 2 meters, 6 meters, and 12 meters. This is a 9 meters, 4 meters, and this line right here is 3 meters. And this is a 5 meters and 8 meters. Okay, so I'm going to give you a little bit, and I want you to see if you can find the volume of each of these figures, and then we'll look at them together. Okay, so for the first one, like I said, I like using the formula that works every time, so that's the one I'm going to use. Okay, so I have the area of the base times the height, because see, then I don't even really need to know which figure it is because I can use this formula every time. Alright, so I have to pick a side for the base because rectangular prism any of the sides could be the base. So I choose this side, this front piece right here. So that's 2 by 6. Well, a 2 by 6 rectangle is 12. So then that makes my height perpendicular. So that's the 12 meters. So 12 times 12. So the volume is 144, but I can't forget my units. So it's 144 meters cubed. Because remember, this first 12 is area, so that's meters squared times 12 meters, so I get meters cubed. And that's for the first one, the rectangular prism. Alright, now the next one. Again, I'm going to use my same formula because it works every time. Okay, I need to find the base. Well, this is a triangular prism, so the bases are the two triangles. Okay, so I have my triangle. Well, the area of this triangle, it has a base of 4 and a height of 3. So I have 3 times 4 divided by 2. So my area of my base is 6. Then the height is perpendicular, so the height is 9. So the volume is 54 meters cubed. Again, always meters cubed, but all I'm doing is the area of the base times the height. Now, could I have done 9 times 4 times 3 divided by 2? Yes, I would have got 54 as well. So either way works. Alright, and then lastly, the cylinder. Okay, again, I'm going to do area of the base times the height. So the base of my cylinder is this circle. So I need the area of that circle. So that's pi times r squared. So pi times 5 squared. Okay, so that gives me 78.5. Okay, then if this is my base, then my height is perpendicular. So that means that my height is 8 meters. So 78.5 times 8. So the volume is 628 meters cubed. Okay. Now again, I could have used the other formula, pi r squared h, but that's what I did anyway, really, right? Because the capital B, the area of the base, was pi r squared, and I multiplied that by h. Okay, so whichever method you prefer, because they're actually the same anyway. Okay. Now, we're going to do one more. We're going to see if you can figure this one out. Alright, so we have this prism. Okay, this length here is 4 meters. The length across the bottom is 8 meters. The length going this way is 10 meters. And this distance right here is 2 meters. So you're trying to find the volume of this prism. Alright, and we'll give you a second and then we'll look at it together. Alright, so first, this is still just a prism. It doesn't matter that it looks different. I can still use the same formula I've been using. As long as I know how to find the area of the base, I can find the volume. Okay, so first I need to identify the base. Well, the base are these trapezoids. So I need to find the area of that trapezoid. Well, I need both bases, right? Well, notice, since this is 4 meters, then I know this is 4 meters. So I know this is 4 meters, 8 meters, and 2 meters. So I can find the area of that trapezoid. Okay, the area of the base is going to be 8 plus 4, because that's B1 plus B2, times height, so times 2, all divided by 2. So that gives me 12 meters squared. because 8 plus 4 is 12. 12 times 2 is 24, and 24 divided by 2 is 12. Okay, so the area of my base is 12. And then since this is my base, my height is perpendicular to it, so I get 10 meters for my base. So the volume of this prism is 120 meters cubed. So see, we can find the volume of any shaped prism as long as we know how to find the area of its base. Because volume is always area of the base times the height for any prism, no matter what the shape.